Welcome everyone. My name is Jeremy Hanemaajier and I'm one of the honors program medical students. During my time at the University of Oxford, I worked on a feasibility study about functional connectivity in motor cortex stimulation for central neuropathic pain. But before I dig deeper into the field of functional neurosurgery, invasive neuromodulation, and chronic pain, I would like to emphasize the reason why this topic got me as a relatively young medical student. I don't want to live this way. Motor cortex stimulation is my last hope. This is an expression of one of the patients I visited together with my supervisor at the outpatient clinic during my summer internship at the Radboud UMC. And actually, since my initial encounters with these severely suffering chronic pain patients, their hopeless situation has deeply resonated with me. As a consequence, it's my main motivation to devote most of my time and energy to my studies to develop the skills necessary to alleviate the suffering of these patients. As an aspiring neurosurgeon, pain neuromodulation has become my primary research interest. Currently, invasive neuromodulation in the field of chronic pain is a rapidly advancing field that has provided chronic pain patients with life-changing relief from the symptoms. And this brings us to my research at the University of Oxford. Before I will explain more about the research I conducted at Oxford, I would like to tell you more about the beginning of motor cortex stimulation. In the early 1990s, Tsubakawa and colleagues introduced motor cortex stimulation as a potential treatment for central neuropathic pain. Motivated by the lack of patient pain relief through deep brain stimulation in central neuropathic pain patients, Tsubakawa began empirically stimulating various brain regions in cats, and they observed that the primary motor cortex in cats could potentially provide excellent pain relief. Later subsequent clinical investigations in individuals suffering from thalamic pain syndrome were in line with the aforementioned findings. However, nowadays, due to the relative lack of mechanistic evidence and highly variable outcomes, there remains active debate around optimal targeting and stimulation parameters. This was also the main motivation to perform the feasibility study during my time in Oxford. Briefly, we figured out a pipeline to conduct connectivity analysis in, to the best of our knowledge, largest motor cortex stimulation cohort worldwide. And as you can see in figure 1, there are several steps necessary to transform patient scans or data to a standardized brain, which we can use to perform connectivity analysis. To investigate the value and feasibility of this pipeline, we included only 2 patients, one responder versus one non-responder of motor cortex stimulation. And between these 2 patients, we found a difference in functional connectivity between the location of cathedral stimulation, so that means there's the negative pole of the electrode, and the anterior cingulate cortex supracallosal and thalamic nuclei. These are 2 different brain regions. This correlation was found to be stronger in the responder than in the non-responder. To conclude, this shows it's valuable and feasible to perform these analyses in the whole included motor cortex stimulation cohort, resulting in the fact that this year I will start with a PhD trajectory in this field to investigate connectivity-based invasive neuromodulation for chronic pain. Where additionally to this motor cortex stimulation cohort, I also will include the DBS chronic pain cohort who underwent surgery at the University of Oxford. This research will identify subcortical and cortical pain network nodes involved in top-down pain modulation, which could inform future prospective neurosurgical trials. In addition, the results of this research will be directly translated into clinical care through optimization of target size, electrode configurations, and parameters in invasive neuromodulation. In short, this research has the potential to transform the treatment landscape of chronic pain, and it is arguable this will improve the abominable suffering and hopeless situation of chronic pain patients.